As we examine the given function, we see that we know that this is the 1.25 is our slope, and the 3 is the output version or output point of part of the vertical intercept. So we know that the vertical intercept is 0, 3. And so we want to create some points based on this slope of 1.25. If you recall, the slope is simply the visual representation of the constant rate of change. And the constant rate of change is the change in output is proportional to the change in input. And so let's first examine what does 1.25 mean. So if we know that this is the change in output divided by the change in input, this numerical is 1.25 over 1. So this means for every 1 unit horizontal movement, there is a 1.25 vertical movement. Okay, so if we know that we have a point at 0, 3, right there, and now we want to move 1 unit to the right, we're going to go 1.25 units up. Well, it's very, very difficult to find 0.25 of a measurement in between these two units. So let's think, what is an equivalent fraction to 1.25 over 1? Well, if we move 2 units to the right, that would mean we'd have to move 2.5 units upward. So if we move 2 units, then we're going to move 2.5 units. And again, 0.5 is easier to approximate, but still, we're not exactly sure where in the middle of these two lines we actually are. I mean, we're halfway, but we don't know where to exactly put that point. So let's, again, see what another equivalent piece to this would be. So perhaps we move 3 units to the right, and that would be 3 times 1.25, which means now we're at 3.75. And you can see that that's also going to be a difficult thing to do. So maybe what we should do is find something that's going to give us a whole unit of vertical change. And so we know that 4 units will give us 5 upward units. So we're going to go 1, 2, 3, 4, 5. So that's now the change of 5, oops, not 5, I'm sorry. That should be a change of 4 units. Let me do that correctly. 1, 2, 3, 4. So it's a change of 4 units, and with that change we're going to go upward 5. 1, 2, 3, 4, 5. So that's a change of 5 units. So we have this new point right there, which is now 4, comma, and just as before we were at 3, we're going to change it 5 units. So that's 4, comma, 8. And we can connect our points at that moment. And if you notice, when we connect this graph, we should go through the other two, but again, these were approximations, so we don't like to use these. We want to make sure that we try and end up with integer coordinate values rather than partial coordinate values, because we're not exactly sure where these are going to lie. We could also, instead of this being a 1.25 and 1, we could always have this be negative of each one of these. And then we could go back 1 unit horizontally and down 1 1/4, which would be right there where the line intersects. And now we know exactly where that would be if this line was, if I had used a ruler to actually connect these 2 points.